Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the derivative rules to find the derivative of these given functions. So as per the problem, so determine prime of f at a for the given function f at x at the given value of a. So we are given these two functions in part A and B, and we have to find the prime of f at x at the given a value. So let's start with part A. So the first step here is to find the derivative of the given function f at x, and that will be prime of f at x, and then we will sub in this a value in that derivative or prime of f at x. Now in part A, the given function is f at x equals x cubed minus square root of x. So in this function, so the second term has a radical on it. So the first step is to convert that radical into a rational exponent. So we get f at x equals x cubed minus x to the power half. Now we can use the derivative rules to find the derivative of the function. So we can use the prime notation. So we write prime of f at x equals, so the derivative of x cubed over dx minus the derivative of x to the power half over dx. Now we can find the derivative of these terms. So for the first term, we'll use the power rule. So the first step is to bring down the exponent to the front of the term as a coefficient. So we get 3, and then we subtract 1 from the exponent. So x to the power 3 minus 1. Now we'll do the same thing in the second term. So we'll use the power rule. So we'll bring the exponent down to the front as a coefficient, and we'll subtract 1 from the exponent. So now in the next step, we can simplify this expression. So we get 3x squared minus 1 over 2 and then x. Now in the exponent, we have to do half minus 1, which is equal to negative half. Now we have to find the derivative at a equals 4. So now we'll sub in x as 4 in this expression for prime of f at x. So we get the prime of f at 4. So we'll sub in x as 4. So we get 3 parentheses 4 squared minus half, and then parentheses 4, and then exponent negative half. Now in the first term, we can evaluate the square. So 4 square is 16. Now in the second term, the exponent on the 4 is a negative number. So the first step is to make that exponent positive, because we cannot rationalize the term if the exponent is negative. So we'll move the 4 to the denominator, and that will make the exponent positive. So there's a very important concept you need to understand and memorize. Now in the next step, we can multiply the terms 3 and 16. So 48, and then minus 1 over 2. Now 4 to the power half in the denominator is equivalent to square root of 4. And we know the square root of 4 is 2. So we get 1 over 2 times 1 over 2. Now we can simplify this term further. So we can do 1 over 2 times 1 over 2, which is equal to 1 over 4. So when we multiply the fractions, we multiply the top terms and we multiply the bottom terms. Now we can subtract these terms. So for that, we'll have to find a common denominator. So the denominator of 4 is 1 and the common denominator is 4. So we'll multiply the numerator and denominator of 48 over 1 by 4. So we get 192 over 4 minus 1 over 4, which can be simplified to just 191 over 4. So this is the value of the derivative of this given function at a equals 4. So now we can analyze part B. So in part B, we have three terms. Now in the middle term, there is a radical on the variable. So the first step is to change that radical to the rational exponent. And that will be 7 minus 6. And then the square root can be written as 1 over 2. And then plus 5x exponent 2 over 3. Now we can find the derivative of this function. So we'll use the derivative rule. The prime of f at x equals the derivative of 7 over dx, then the derivative of 6x exponent half, and then the third term plus the derivative of 5x exponent 2 over 3. Now we can find the derivative of these terms. So the first term is a constant, and we know the derivative of a constant is equal to 0. Now in the second term, we can use the constant product rule. So we can move the coefficient 6 to the front of the term, so minus 6, and then it's just the derivative of x power half over x. And we can do the same thing with the 5, so we can move the 5 to the front, and then it's a derivative of x to the power 2 over 3 over dx. Now we can simplify this expression further. So negative 6. So now here we have to use the power rule for x to the power half. So the exponent is half, so we bring it down to the front of the term times x to the power. We subtract 1 from the exponent, and then plus 5. Now we use the power rule for this term, so we multiply by the exponent 2 over 3 times x, so 2 over 3 minus 1. Now we can simplify this expression further. Prime of f at x, so negative 6 times half is equal to negative 3, and now the coefficient of the x is negative 1 over 2. So half minus 1 is negative half, and then plus. Now in the second term, we have to multiply 5 by 2 over 3, which is 10 over 3, and then x, and now here the exponent is negative 1 over 3, because 2 over 3 minus 1 is negative 1 over 3. Now we can move these x terms to the denominator to make the exponents positive. So prime of f at x equals negative 3 over x to the power half plus 10 over 3 x exponent 1 over 3. Now we have to find the derivative at x equals or a equals 64. So we'll sub in x as 64 in this expression. So we get prime of f at 64 equals the negative 3 over 64 exponent half plus 10 over 3, and then 64 exponent 1 over 3. Now we can simplify this expression. So the prime of f at 64 equals negative 3 over. Now 64 exponent half is the same as square root of 64, which is 8. Then plus 10 over 3. Now here we have to do 64 exponent 1 over 3, which is basically the cube root of 64, which is equal to 4. So we are left with, so prime of f at 64 equals negative 3 over 8, and we can simplify this fraction, so we can reduce this fraction by 2, so we get plus 5 over 6. And now we can add these two fractions, and for that we have to find a common denominator. So the common denominator here will be 24. So we'll multiply the first fraction by 3 in the numerator and the denominator, and we'll multiply the second fraction by 4 in the numerator and denominator. So we get, so we can just move here. So prime of f at 64 equals, so it'll be negative 9 over 24 and then plus 20 over 24, which is equal to 11 over 24. So this should be the final answer for the derivative of this given function f of x at x equals 64. So these are the steps you have to keep in mind to calculate the derivative of a function at a particular value of the input variable x. So first we have to find the expression for the derivative, and then we sub in the input variable value to find the exact value of the derivative. So I hope you'll find the video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.